Hello and welcome, and thank you for joining us for this overview of the OptiView XG Network Analysis tablet. It's rare to find a network operations group these days without some sort of tool set for managing performance and troubleshooting problems. At the very minimum, some sort of network management system or polling software, and Wireshark, sometimes numerous different tools. But even so, we find that many network engineers still struggle to resolve issues quickly, and with the impact of application and network slowdowns costing organizations thousands of dollars in revenue or hundreds of hours of employee productivity, network managers and infrastructure directors are coming to us looking for ways to improve their processes and tool sets to minimize these losses. Fluke Networks designed the OptiView XG to be a dedicated tablet for network engineers whose responsibilities can span from the access layer, either wired or wireless, to the distribution layer, uplinks, aggregation points, the data center, server farms, WAN, remote sites, and cloud services. It's unique because it's an all-in-one tool that combines the essential functions of a network management system, hardware-based packet analysis, multiple wireless analyzers, and performance testing at up to 10 gig speeds in a portable tool, giving the engineer insight into the network from anywhere. The OptiView XG features custom hardware for line rate packet capture and performance testing, which is better than using Wireshark or iPerf on off-the-shelf laptops, which can only handle a fraction of the traffic on typical network links. Instant network mapping and path analysis for both wired and wireless networks either immediately proves it's not the network or shows where the engineer needs to go for the next troubleshooting step. Automated expert analysis and the graphical presentation of information isn't just more data, it's answers. Answers that reduce the time it takes to identify and resolve performance problems by up to 75%, or, as many of our customers have told us, from days, weeks, or even months down to minutes. Are you interested in finding ways to improve your response time to performance issues? Let's take a look at how the OptiView XG can help. Here we see the home page of the XG user interface. The home page has multiple customizable dashboards to consolidate and present information about the network in a way that is quick to understand. Network engineers want to have an up-to-the-minute sense of what is happening on their network, and XG gives that to them here. Next to the home page is XG's discovery information. OptiView's network analysis function discovers the network, the attached devices and infrastructure elements, and where they are connected. Next, XG queries these devices for detailed information about each device, categorizing it by type, and gathering information about its health. XG then takes this information to instantly draw a map of the network. Here we see XG taking the collected information from discovery, drawing the devices on the network, the interconnections, the names of the interconnections and interfaces, and noting any health metrics or information about that particular device. This is an interactive map where I can simply double-click on an item to bring me to the detailed information about that device. In this case, we see that this device has some frame errors on it and was rebooted in the last 5 days. So in a way, the network map itself becomes a way of visualizing the network, looking for problems, and being able to start troubleshooting. It's important to note that this map, when I hit the report button, will instantly create a Visio diagram. So this is a way of keeping your documentation up to date, having instant, accurate maps of your network. But let's take a look at how you would use the XG in a typical troubleshooting scenario. Let's say we've got a particular user who's complaining that the network is slow, but only for a particular application. The first step in troubleshooting is to understand the connection path between that user and the resource they are trying to access. For that, we'll use XG's path analysis function. Here we see the path analysis feature. This features a starting point and a destination point. We will select the user's PC as the starting point for our path analysis. For this demo, we'll call it PC 16. The resource they're trying to access is the Oracle application. Here's a server that's involved with the Oracle application, so we'll set that as the destination device, and then hit Start Analysis. What happens now is that XG combs through its discovery information, using the information we know about the devices and their interconnection points, to draw the exact path from that source device across the layer 2 path, the layer 3 path, and the layer 2 path at the far end of the network to that destination device. And we're recording and showing all of the interconnection points along the network along the way. Instantly, we can see that between the user's access layer switch and the next hop up, this layer 3 switch, we're having some errors. Let's look into those. You'll note that each device where there's an error or problem occurring, a little warning sign will appear. The warning sign on the interface itself says that that interface is having errors, and we can see that in the chart illustrated below. Both the port exiting the access layer switch and the inbound port on the layer 3 switch are showing that errors are occurring. So let's drill into those to see what's actually happening. We can see that this switch is reporting FCS errors on this port. Likewise, if we look at this interface on the layer 3 switch, it also is reporting FCS errors. Clicking in, OptiView takes us directly to the interface in question. We can see that the speed of this interface is 100 megabits per second, and the two full arrows indicates that it is a full duplex connection. But sure enough, there are the FCS errors that we're seeing on this port. Going back to the other switch, let's click through on that interface. And it, again, takes us to that particular port, port 24, on the access layer switch. This is an uplink port. It, too, is set at 100 megabits per second, which may be a problem in the first place. Why is my uplink at 100 megabits per second? But most importantly, we're seeing a solid arrow and a hollow arrow. That is indicating a half duplex connection. So we have a half duplex, full duplex connection, which means there's a duplex mismatch on this link, and that is creating FCS errors. When FCS errors are created, frames are lost. When frames are lost, TCP tries to recover by issuing retransmissions. That is the cause of the slow application. So now we've found a network problem that is causing an application performance problem. But what if? What if our path analysis revealed no problems along the path? That is, there were no errors to be seen whatsoever on the network itself. Well, if that's the case, no errors on the network, then we've instantly proved it's not the network. And in fact, if we need to, we can click the report button to create a report that we can hand off to someone else. Here's what that report looks like. So, if I had to provide evidence to someone that there was no issue on the network, I could simply create a report and hand it off to them and show them that I'm all green. Of course, in this case, in this example that we do have errors on the network. But let's just say we're going to take this troubleshooting process another step. If the network is clean, we've proved it's not the network, the user is still experiencing a problem. So what are we going to do next? Well, we can use the path analysis information to tell us where do we need to go to get in the path of the packets to see that application transaction between that user and that application directly. If the network's not at fault, we need to determine, is it the user, is it the server, is it the application itself? To do that, we have to get to the packet level. We can use this information about ports and interfaces to get to a particular interface that may be co-located with me, the network engineer, and I can go to that router or perhaps another layer 3 switch somewhere, and I can span that traffic from that device out to my analyzer. So in this case, I'm going to move my OptiView to that point so I can get in the path of the packets. At that point, with the network under test port connected to that switch and receiving that span flow of traffic from the interfaces in question, I can then select the traffic analysis feature of OptiView. Traffic analysis is showing you the real-time analysis that OptiView is doing on its custom hardware on the packets that are being received. Here we see, well, it's called local utilization, but this is the traffic that's coming into the network under test port. You can see that OptiView is categorizing that traffic by type in terms of unicast, multicast, broadcast, and errors. But then the related task area at the bottom of the user interface becomes very important to us. We want to be able to view perhaps the top hosts on that traffic that we're seeing. OptiView then shows us the top host by specific protocols. So we can select a particular protocol tree, and we can see what hosts are sending what level of traffic on that particular link. It may be that we can see the traffic from the user and the application that's in question. I might want to move to top conversations by protocol to see that. And I may actually find that user and that server in the conversation mix. If I do, I can simply select it and then go to create packet capture filter for that selection. And that takes me immediately to my packet capture screen. Now, because I'm using a demo database, I may have selected a conversation here that may not really exist in real life, or at least in the traffic that we're seeing. So I'm going to change my filters to be any source, any destination device, and then simply hit Start Capture. OptiView warns me that I may be overwriting some saved captures in my file, in my buffer. I'll just simply say yes. And the status line down here that indicates what number of frames I've matched is indicating that we are indeed capturing traffic. Let me stop traffic capture, and then we'll go to view the traffic capture. What's happening now is OptiView is passing those packets over to ClearSight Analyzer. And ClearSight Analyzer will open that trace file and put it into view here. So OptiView has passed that traffic over to ClearSight Analyzer, and ClearSight Analyzer, our commercial packet analysis software, has opened that trace file. Now, ClearSight, much like Wireshark, can offer you decodes of packets. This is basically your traditional packet decode, packet analysis software. And like Wireshark, we can look at packet decodes, we can see frames, we can see the decodes, we can see the hex code. And for the highly experienced network engineer, they may be able to look at the hex code and say, well, row 20 offset 835, that really needs to be 7F, and that's your problem right there. But, most of us humans can't really look at hex code and determine what the problems are in a trace file. And that's why ClearSight Analyzer gives us the ability to visualize traffic flows. This is the ClearSight view. This is the summary view at the application layer, showing us all of the flows that are involved in the traffic that we captured, putting it into a graphical view, showing us what are the specific application flows that we've captured, how much of the traffic or how much of the bandwidth of the trace file that particular traffic is taking up, and if there are any issues within that specific application. At this point, I'm going to switch to our demo trace file because I'm not sure what I captured off of the OptiView demo mode. The demo trace file is far more interesting to take a look at. Again, starting from the beginning, we have decodes, but who wants to look at decodes? We really want to be able to get to answers about what's going on in that trace file and why is the application slow. So we're going to switch over to the ClearSight view. So at the application level view, selecting ClearSight and Summary, we get to that graphical overview of all of the flows that we see within that trace file. The expert analysis is already showing us that we do have some issues that warrant looking into, but we're primarily interested in the Oracle flow because, well, that's the problem that that particular user was having. So let's click through onto that flow. So here we see the specific flows associated with the Oracle database. On each one, we're going to indicate, so there are two Oracle flows that we've captured here, and the little red icon indicates that there's a problem within that specific flow. By switching to the conversation view, we see the actual ladder diagram of the user talking with the server and seeing the requests go in from the user and the responses come back from the server. ClearSight is identifying that there are some specific frames that contain errors. And these are the ones that are causing that red indicator on the severity indication up here where we're showing the flow. But as I go through this particular trace file, I see some frame errors, or excuse me, some database error notifications, but I don't really see anything that would indicate that this particular flow is slow. Let's take a look at the other flow, and let's pretend for now that this is the flow of concern between us and that particular user that we were trying to troubleshoot before. We see the application flow, we see the requests, the response from the server, and we can navigate down through the trace file, through the ladder diagram, and we can see that at one point, a request goes into the server, and the server takes 79 seconds to respond to that request. So, in this kind of troubleshooting scenario, we've gone from looking at the network, proving it is or is not the network, using the information from OptiView to be able to get us to a point in the network where we can capture the relevant traffic, and then use ClearSight Analyzer to graphically show us where the problem is. We've gone from the bad alternative of using Wireshark to look at decodes to using the ClearSight view to graphically see the flows of traffic in an understandable format. We've been able to drill into the traffic flow in question. We've selected that flow and gone into a ladder diagram so that we can visually see the conversation of the client with the server. And we've identified a specific set of information or requests that went from the client to the server that caused the server to hang. What's next in the troubleshooting workflow? Well, we've got some evidence. And because we have this evidence, we can go to the TCP data tab and we can save that information as a text file. And I can now give that information to my DBA or my server guys and say, hey, look, I've already proved it's not the network. Here's my report that shows you that. I've found the user's conversation with the database, and I've identified that there is a significant problem occurred when a specific request went into the server, and here's the information that went in so you guys can solve the problem. So that's just one simple example about how we can use OptiView to discover our network, to identify issues on devices, to conduct path analysis, to determine, is my network clean or is there a network problem? I use this path analysis information to tell me where do I need to go to get additional information. I get into the path of the packets and I can see the conversations that are occurring. I can filter on a conversation, create a packet capture filter. I can capture the traffic that I'm interested in, and I can then go to ClearSight Analyzer. I can look at the packets in decode, but who wants to do that? I can look at those packets graphically, see the flows that I've captured. I can immediately narrow down to the application of interest, and then I can get to the flow in question and identify the root cause. As simple as that. For many of our customers, that is to say, for most of our customers, they may not actually be a customer for both OptiView and TrueView. And the example that I've run through shows you how a user with just an OptiView from Fluke Networks can go from monitoring the network to identifying problems to analyzing the path and getting to the root cause of a specific application problem. But for those customers to whom we can also sell TrueView, or to whom TrueView is a good opportunity and a good solution for them, let's take a quick look to see how OptiView, working with TrueView, would solve this particular problem. So let's say I've got TrueView on my network and I've got OptiView connected to my TrueView. That is, when I go to the end user response time feature in OptiView, which is the linkage with TrueView, I can actually get to TrueView data. I can select that particular client. Let's switch back down here to the PC16, and my application is Oracle. So here we'll see how OptiView and TrueView together can speed the troubleshooting of this particular problem. All right, so here's the information imported from TrueView into OptiView about that client, about that application. On the lower left, we see the end user response time heat chart. This is indicating that clearly we have a network related issue. And if we look over here at the right-hand side, the client versus site EURT, we see that the client site, which is Springfield, is experiencing EURT of about, let's say 275 milliseconds. But PC16 is experiencing EURT of about twice that. So we already know that it's something that's affecting that user, but not the entire site. So essentially right away, I can see that in this particular example, again, we're going down the path of this network-related issue. We can automatically know that it's not a problem with the application. The heat chart has identified that it is a network problem, and it's not affecting all the users at that particular site. By flipping around the EURT heat chart card, we can see that the problem is around retransmissions. ART is not a problem, no problem with NRT or any Windows issues, but it's retransmissions that are the issue. So let's click through here to EURT breakdown, and that's going to take us to the TCP health metrics. So here we see that retransmissions are high. There's no issue with zero windows or out of orders. We've identified that retransmissions, and again, remember that retransmissions can be caused by packet loss. It's retransmissions that are causing our slowdown. And the information we found in path analysis showed us exactly what the root cause was of those retransmissions. So this is how path analysis and EURT information from TrueView working together can really quickly get to the root cause of performance problems. I hope this brief example of a golden demo shows you a way that you can demonstrate to your customers within just a few minutes some of the core strengths of OptiView XG and how they might put it to use to solve very specific user-related problems on their network to get to both network-related root cause and application or server-related root cause. Thank you very much.